Okay, task 2 requires us to do assembly programming. In task 2, we've been provided with several instructions. So this is our instruction set. We are going to use all of these instructions or some of these instructions to accomplish the task provided. Okay, now what is assumed is that our CPU has one accumulator. It has a single accumulator, so it has one general purpose register, and the only general purpose register is what? The accumulator. So this is the only register inside the CPU to hold data values, right? So we have one accumulator, right? All the other registers are special purpose registers. Yes, there are other registers, but we only have a single accumulator. Okay, and we only have a single index register also. So if you remember what the CPU looks like, the CPU has many special purpose registers like the program counter, like the MAR, like the MDR, but the only general purpose register is what? The accumulator, and we only have a single accumulator in our CPU, and for this scenario we also have a single index register within the CPU. So that's the information that has been provided. Okay, let's take a look at the different instructions, right? LDM with this hash sign, right? N, this is used for immediate addressing. So this instruction is used for immediate addressing, which means what? Which means if this is our memory, this is our memory, right? And this is the accumulator, right? And this is our index register. If we do something like this, LDM number 77, right? So this, with this hash sign, this means this is immediate addressing, and in immediate addressing, this value 77 is going to be directly loaded into the accumulator. So that's what LDM is used for, using this value and directly loading it into the accumulator. Okay, let's take a look at this one. This is used for direct addressing, and in direct addressing, if we are given a command like this, if we are given an instruction like this, LDD 27, that means go to location number 27, take this value 95 and load it into the accumulator. So our accumulator will now have this value 95. Okay, how about this instruction LDI? This uses indirect addressing. So what if we get an instruction like this? What if we get an instruction like this? This is our opcode, right? This is our opcode, and this is the operand, right? So if we get an instruction like this, go to location number 25 in the memory, and whatever value is stored inside is another address. So this value 31 is basically another address, right? So so this means from here go to this address, which is address number 31, right? And this is the value that we have to load into the accumulator. So this is indirect addressing. First go to location number 25, there you will find an address, go to that address, and at that address you will find your value, which in this case is 86. So when this instruction gets executed, 86 is going to be loaded into the accumulator. So previously we have 95 in the accumulator, and that value is going to be overwritten, and now we are going to have 86 in the accumulator. Okay, how about this one, LDX? LDX is indexed addressing, and in LDX, let's take an example of LDX. Let's say we have this instruction LDX 26. Okay, what's going to happen when this instruction gets executed? The address this time is going to be calculated using the index register. Remember, this is index addressing, and it uses the it uses the value inside the index to calculate the new address. So the address that we are going to have is going to be this value 26 plus the value inside the index register, which is going to be 2. So 26 plus 2 is what? 28, right? So we are going to go to location number 28, and the value there is going to be loaded into the accumulator. So this time the accumulator will be loaded with this value 45. So the old value is going to be overwritten, and this new value 45 is now going to be loaded into the accumulator. This is 45, right? Okay. How about this instruction LDR hash n? Remember, hash means this is immediate, right? So we are using immediate addressing like we used here, right, in LDM, but this command is used to load a value directly into the index register. So What if we get an instruction like this, LDR hash 4? What this is going to do is, it's going to load this value 4 into the accumulator, right? So our accumulator will take this value. So this is basically immediate addressing that we are using. So previously we used something like this, right? LDM hash 33 for example, and this would load this value 33 into the accumulator. This LDM was a command that was used for immediate addressing for the accumulator, and this LDR is a command that is used for immediate addressing for the index register. And in immediate addressing, the value that has been provided in the operand is directly loaded into the, in this case it is directly loaded, this 4 is directly loaded into the index register. In this case 33 is directly loaded into the accumulator. So this is going to be overwritten with 33. So these are immediate values, right? These are not addresses, rather these are immediate values. Okay, so next we have these store instructions, right? We have this store instruction, and what store is going to do is, if we say store something like, store 29, now this is going to store this value which is in the accumulator at this address 29. So this value in the accumulator, which is 86, is going to be stored at this address in the memory, right? At this address in the memory 29, right? This is where we are going to store this value. Okay, so how about this instruction add, right? If we get this instruction add 25, then this is going to do what? We are going to go to location number 25. We'll bring this value into the CPU, and this value 31 is going to be added in the already existing value in the accumulator. So accumulator already has a value of 86. This value 31, which is stored at location number 25, this value 31 is going to be added to the value in the accumulator, and we are going to get our result 117. This new result is going to be saved into the accumulator. So the old value 86 is going to be overwritten, and this new result is going to be saved in the accumulator. Okay, the next one that we are going to do is increment, right? Increment adds 1 to the contents of a register, right? So in this case the operand is not an address, but it is a register. So we can do something like this. So increment, this command will always have a register, right? So if we say increment index, right, this is going to increment the index register by 1. So the value of index register is 4 right now. When we add 1 to it, it becomes 5, right? If we have this command increment accumulator, this is going to increment the contents of the accumulator, right? So if the value already existing in the accumulator is 86, when this instruction is executed, then this value becomes 87. So this value is incremented by 1. So now when this instruction gets executed, this becomes 87. Next is this instruction decrement, and in decrement once again we have to mention the register. Okay, so what if we have decrement index register? Decrement index means reduce the value of the index register by 1, right? So the index register already has a value 4. This is going to be decremented by 1, and this is going to become 3. If we write something, if this is the instruction that we have, decrement accumulator, then the accumulator already has a value of 86. When this value is decremented, 86 minus 1 becomes 85. So the accumulator is updated to 85. Okay, let's solve task 2.1. Okay, in task 2.1, this is what we're trying to solve, right? This is what we're trying to solve, and he's given comments here, right? So we are going to follow whatever these comments are saying to accomplish task 2.1. For example, he says load the contents of A into accumulator. So what he's saying is go to location number A and load those contents into the accumulator. So this is direct addressing. This is direct addressing, and the command for direct addressing is LDD. So what we are going to do is we are going to say LDD, and this is where we are supposed to write the address. So we are going to say LDDA. So we've executed command number 1. So what this is going to do is this is going to load the contents of A into the accumulator. So our accumulator at this point in time will have the value that was located at, the value that was held at this address A, right? And that value is 5. So our accumulator will now hold this value 5. Okay, and the next command is, this next command says add the contents of B into the contents of accumulator, and the command for that is add, right? So the add command, the opcode is add, and the operand is the address, right? And the address in this case is going to be what? B. So add B is going to do what? We are going to go to location number 3, get this value at location number, so we are going to go to location B. We are going to go to location B. This is the address, right? So we are going to go to location B, take this value 3 which is loaded at address B, and this value is going to be taken inside the CPU, and inside the CPU the already existing value in the accumulator is going to be added to this new value 3, and the result is going to be stored into the accumulator. So the accumulator will now have 5 plus 3, right? 5 plus 3 equals 8. So our accumulator will now be updated to 8. So that's the value that's going to be held in the accumulator. So this command has been executed also. Okay, let's take a look at this comment. This comment is saying store the contents of the accumulator at address X. So this is once again involving direct addressing, right? We can store at X by using the command store X. This is the opcode store, and this is the address where we have to store the value, and the value that is going to be stored is the value that is held in the accumulator. So this value 8 in the accumulator is now going to be stored at this location, which is pointed to by X, right? This location which has this label X, right? So this location, at this location, this value 8 which is in the accumulator, this value 8 is going to be, let me rewrite that, this value 8 is going to be saved at this location X, and finally this end instruction is ending the program.